Shake Table Lab by Charlie Cushman and Rohan Joshi. Construction number 1. We sketched out plans for our building so we would know what to build. Construction number 2. We secured the building to the cardboard base plate so the building would have a solid foundation. Construction number 3. Next, we cut out straws to the right length for the building's cross braces for extra support. Construction number 4. Cross braces would make our building stronger. Construction number 5. Each floor was reinforced with cross braces. Project dimensions. The first floor of our story was 21 centimeters tall. The second story was 18.5 centimeters tall. The base of our building was 19.5 centimeters tall, and the width of the second story was 16 centimeters tall. The width of the first story was 18 centimeters tall. Testing. We tested our building by putting sandbags on our structure before putting it on the shake table. The structure did support the weight, so we knew that our structure would be strong. Strengthening. We used tape to strengthen areas in our building that were weak, such as the joints where multiple straws came together. Strongest parts. The cross braces were the strongest parts on our structure because triangles are very strong. Triangles provide strength, like in the Eiffel Tower and the pyramids. These cross braces supported the weight of the floors with sandbags on them. The tape makes them even stronger. Weakest parts. This lone straw is very weak because there's nothing else to support it. Other straws like this one were also weak. Tape. We use tape to connect straws at major joints, at cross braces, and to connect straws to make them longer. Extra supplies. If we had extra straws, we would have put them in the middle of each floor. We would have done that because it would have given us extra support beneath the weight of the sandbags. It could have supported the middle in addition to what we have now, which is only this on the sides. Oh, shoot.
Oh my god.
Wait, it's like not... Dang it. Wait. Earthquake sensor. This was what the earthquake sensor showed when our tower fell down. There are 3 different measurements, and you can see that we had short but fast shakes. The x-axis, in green, showed the back and forth motions of the shake table. Hi, I'm Charlie Cushman, and this is our building for the shake table that I made with Rohan Joshi. And our building supported 5 sandbags. It supported 3 on the middle floor and 2 on the top floor on the shake table with a major earthquake. Our building failed right here. You can see the straw is bent and ripped up. That's right where the building collapsed. And if I were to build this over, I would have put a lot more tape on the base, these straws, so it wouldn't have been moving up and down as much. So it would have been anchored to the base better. And also I would have tried to make sure that we built it as straight as possible because it was a little crooked before we put it on the shake table, and I think that cost us sandbags. So during this project I learned that when you build things, triangles are the strongest shape. As you can see, we made cross braces to have 4 triangles on each side, and many buildings have triangles in their big skyscrapers and strong buildings. And so I also liked that this lab it was all hands-on and that we could build it all ourselves, and Mr. Clausette wasn't helping unless we really needed him to. So what people building did was really what they could build themselves, not what Mr. Clausette built, so it got more competitive between students, and so that was fun. And so, yeah, it's our building.
Hi, I'm Rohan Joshi, and I am Charlie's Shake Table partner for the Shake Table Lab. And in the Shake Table, our building supported 5 sandbags, 2 on the top, 3 on the middle. And the point of failure for us were the bottom straws, such as this one, that completely broke and they almost snapped in half. And this really cost us because that's what took it down. And if I were to build it over, I would have made the base wider so that it could go in and have pressure going towards the top so that it wouldn't fall down as easily. And I would have also made it not as crooked because it's really crooked right now, even after it fell. And I learned that earthquake-strong buildings have to have triangles, which are the strongest geometric shape. And to incorporate triangles in your building, you can make cross braces such as this X on your building so that when pressure goes down on this part, it just meets in right here, and if it's not broken like it is right now, it won't usually tremble. So that is what I learned. And what I liked about this lab was that Mr. Clausette didn't really help much, and it was just me and Charlie. And yeah, so whoever won, it wasn't Mr. Clausette winning through them, it was them winning actually, and it's an accomplishment. And yeah, so that's what I learned, and that's what I liked about it.